Algebra 2, Lesson 83, Variable Exponents. So, we're going to be talking about a rule we already know called the power rule, which quite simply means this. I'll go ahead and repeat the example in the book, but if we have two numbers that are exponential to the same base being multiplied, like x to the power of 3 times x to the power of 9, we can simplify that by adding the exponents. X to the power of 3 plus 9, which equals x to the power of 12. Now, we're just going to be doing this rule right here. However, we're going to be doing it with some complex fractional exponents and then also some exponents that include variables or unknowns. So our first example, let me see if I can get this down right. We have x to the power of a times y to the power of 2x. And we have x to the power of a divided by 2. And then y to the power of 3x divided by 4. So again, to use this power rule, we have to group numbers that have the same base. So in this case, a will be added to a over 2, and then y will be added to, for y, 2x will be added to 3x over 4. So if we were to split this up based on x's and y's, the x could be rewritten as x to the power of a plus a over 2, and y can be written as y to the power of 2x plus 3x over 4. Now there is another way to there is a better way to simplify this, is we can give these whole numbers, turn them into fractions, get common denominators, and simplify it to a single fraction. And that's what we're going to do. So all we have to do now is just do some addition of abstract fractions. For the x's, dealing with just what's going on in the exponents here, we then make this a over 1 plus a over 2. We multiply by a value of 1 as 2 over 2. So then what we actually have is 2a plus a all over 2, which gives us the exponent of 3a over 2. So this is going to replace that. So for our answer, we'll have x to the exponent of 3a over 2. Now, that's only the x though. We still have to solve for y. So we'll take the y right here. We have 2x over 1 plus 3x over 4. Common denominator is going to be 4. We multiply by 1 written with 4s. That gives us the problem 8x plus 3x all over 4. And then that simplifies to become 11x over 4. And this is going to replace our exponent for y, which I will write down here in the green. So then we get y to the exponent of 11x over 4. And this is our final answer. So that is variable exponents. We're just using rules we already know, but the numbers look a little bit scarier. So let's see if we can find another example here. Okay, we'll do here. So this is a really quick one. This is a small problem. They have x to the power of a plus 2 in parentheses, and then outside of the parentheses we have the exponent of 2. So here what we actually do is we distribute the exponent. So we'd multiply here because it's outside of parentheses. So what that would do is it would make our final answer x to the power of 2a plus 4. Right? So that one's pretty simple, but it shows us something else that may happen. Is we may have an exponent outside of, a complex exponent, and then we'd have to use distributive property. And this is the hardest example I can find. Let me get this one on here. So we have x to the power of a being multiplied by b Then we have y to the power of a with, outside of that, b plus 2. All of that is over x to the power of negative a. So how are we going to deal with this? First, let's go ahead and make this negative a positive. So we'll move that up to the numerator. It becomes x to the power of positive a. And then from there, we're going to simplify these exponents. So this is going to multiply, and this is going to multiply. This one is going to become, I'll go ahead and rewrite over here. It's going to become x to the ab. This one will become y to the ab plus 2a. So here I'm using distributive property. The b times the a, then the 2 times the a. That's what we've got now. So now all we have to do is just add these two exponents. So when we add these, we get x to the exponent of a plus ab, y to the exponent of ab plus 2a. That's your final answer. And that's it for variable exponents. I mean, we're just using these different rules that we already know. We have to use some rules of distributive property, some rules of adding and combining fractions, and then that's going to help us deal with these exponents that have these unknown values in them. So if you have any questions, let me know on Moodle, and I will see you in class.